This video will deal with Fermi's paradox. For purposes of this video, I will assume the laws of physics as we know them apply to the rest of the universe. We still have a ways to go to get physics right, but we are pretty close. Two of those laws are that it is impossible to go faster than the speed of light, according to the special relativity theory, and second, there is a conservation of momentum. Fermi's paradox is that we are in a very large universe with a very large amount of time, and so we would expect there to be a large number of civilizations in the universe that are communicating by radio waves, and we should be able to pick up those communications. However, currently we are not able to. There are a number of potential life forms that could exist. First, there could be carbon or silicon-based life forms. Second, there could be mechanical life forms. I will define all life forms that are not silicon or carbon-based as being mechanical. Third, there could be a combination of mechanical and organic or silicon-based life forms. And fourth, there could be life forms that switch back and forth between being mechanical and silicon or carbon-based. The basic point of this video is to answer Fermi's paradox by saying that any civilization that is out there has done the calculations and figured out that interstellar travel or communication is not worth the effort. Additionally, they just might not be out there. If in fact they developed the technology to do interstellar travel, then they would apply the technology where they are and live better. For example, assume the Star Trek transporter technology actually existed. Then you would be able to make copies of yourself, or have the ability to make copies, so that if something happened to you, someone would just hit the make a copy button and there would be another you. Similarly, if you needed a new body part, you could generate it. If you had a diseased body part, it could just be run through the transporter, have the diseased body part replaced with a healthy one. The most likely conclusion is there are not a lot of life forms out there. There is also the possibility of there being a technological singularity. That is the notion that sometime soon technology will make a breakout and we will become super intelligent and be able to solve problems that we are not able to solve now. My own prejudice is that if we make it to 2040, a lot of people will be Borg, as in Star Trek Borg. A technological singularity is an interesting thought, but if you take the most knowledgeable physicist and the least educated person, and if they each drop a ball, it will fall at 9.8 meters per second squared, regardless of which person dropped it. Our fastest spaceships travel about 40,000 miles per hour. To do interstellar travel, you either have to be able to time travel or get your spacecraft going near the speed of light. If you compare our current best speed to the speed of light, the ratio would be as 2 inches, which would be our best speed, is to the length of a football field. In increasing speed, the problems of going faster become harder the faster you go. Some say the energy requirement to go the speed of light would be infinite. We all develop prejudices as we go through life. These have to do with how we think the universe operates. One prejudice we have is that when you're traveling in a car, airplane, or boat, if you shut off the power, you will soon come to a stop. To accelerate a space vehicle to nearly the speed of light and have a human crew survive, you would have to accelerate for nearly half a year at a distance that would be roughly 200 times the distance of Pluto is from the Sun. If you got the spacecraft going at nearly the speed of light and you wanted to be able to stop, you would have to have a device that would slow down the vehicle over a similar distance and period of time. If you like Star Trek, or I like Star Trek, but it has always concerned me that the crew is not splattered on the back wall when they accelerate into warp drive. Accelerating to near the speed of light would take a device that is longer than our solar system, and being able to stop would mean that you would have to have a similarly sized device waiting for you to deaccelerate you at the end of the trip. The next hope would be to be able to time travel backwards and forward. The only way this would seem to be possible would be if you could open a wormhole. The only way to open a wormhole, if it is in fact possible, would be to use an amount of energy equal to that of an exploding star. The wormhole, if it were opened, would be very unstable and could not be kept open using any known materials. The release of the amount of energy necessary to open a wormhole would kill anything that could use the wormhole, so time travel is not an option. For the above reasons, we in similarly situated carbon or silicon based life forms, when they start thinking about interstellar travel, would come to the same conclusion about it, that it is not possible. It is my understanding that if we were to send astronauts to Mars, it would cost about $1 trillion for the first trip, and by the time they came back, their bones would be so depleted of calcium that they would have to be in a wheelchair. The only way interstellar travel could be done is if someone were to send out pods that either were mechanical life or were capable of reconstituting organic or silicon life from their constituents. This would sort of be like a Van Neumann machine. However, the travel plans would be over hundreds of thousands of years. The elements of Earth are not a lot different from the elements of the rest of the universe. My own guess is that if someone wanted Earth's iron for something They would come here, flush the atmosphere and crust to eliminate the corrosive atmosphere and haul the big ball of iron to wherever. The second way of having space travel would be looking for others by radio transmission. If you look at the various websites where people make comments and how much misunderstanding there is of people who speak the same language, think of how much misunderstanding there would be if there were no points of reference in common and there were gaps of years or centuries between transmissions. For example, say we sent out a message that said we live on a planet about 93 million miles from a yellow dwarf star. Would you like to chat? Say in 150 years someone picked up that message without decoding it and sent a message saying, "We received your message. We haven't figured it out yet, but we would like to chat." The message would take 150 years to get back to Earth. So 300 years later from when the first message was released, we may have an answer to the original message. It would likely not be in an Earth language and would have to be deciphered. Given how things change on Earth, think of the probability of there being part of the social structure that sent the original message still being around. The real interesting question becomes, how long can a population with radio communications technology continue to exist? If you think about what goes on in our day-to-day existence, from the moment of conception until the day of your corpse having its last bit of carbohydrate broken down to water and CO2, there is something trying to eat you. Similarly, you are nearly continually in need of food to provide your body with energy and materials to repair it. To survive, many mechanisms for self-survival evolved and continue even though they are no longer necessary. We are emotional beings that think and not thinking beings with emotions. Some of our survival methods have in fact become more dangerous than the things we are to protect ourselves from. For example, nuclear bombs. It's not likely that the countries of the world will get together and commit mutual suicide by having a nuclear war. However, you have to think about a country like Pakistan. It has large lawless areas. It has extreme fundamentalist groups which are very militant. And it has nuclear devices which are about the size of soccer balls. They have India on their east, with whom they have fought a number of wars. On the west they get pressure from Al-Qaeda, the Taliban, and the United States. There is little doubt in my mind that if Al-Qaeda got a nuclear weapon to New York City, they would detonate it. There is the Israeli nuclear program. Israel's nuclear arsenal is set on a hair trigger. There are about 5 or 6 million Israelis surrounded by 300 million Arab Muslims who do not want them there. In parts, Israel is only 50 miles wide. If there comes a time when Israel would appear to be being overrun, I would not want to